For my DS4100 final project, I created a model to predict the revenue of a film when given a link to its IMDb posting. Sources for information were film and actor information from IMDb and revenue information from Box Office Mojo. When writing my scraper, I wanted to pull as many features as possible. The original intent was to backwards fit a model once I gathered everything, so I kind of wanted to get it all up front so I didn't need to go back and fill in blanks. Some of the features that I grabbed were the weekday that a film was released, so Monday through Sunday. I converted that to an integer of 1 through 7. The day of the month the film was released, the month, the estimated budget of the film, the length in minutes, the MPAA rating such as PG-13, but this was converted into an integer, and I'll talk about that more later on. Some actor-specific information. Average actor age was calculated by going through the array of actors in a film and averaging their age. Max actor film revenue was calculated the same way by going through the array of actors, and this returned each actor's maximum revenue, and then it took the single maximum from that entire list. So there's a pattern here. Max actor film votes is the same kind of calculation as it was for revenue. Film votes are the number of people that voted on IMDb, and that would create a star rating from 0 to 10. Number of film appearances is how many movies an actor has been in. Metascore is a rating from 0 to 100 that critics give a movie. Director age is similar to actor's age. That's just how old the director was when the time the film was produced. The number of films the director had directed before this film, maximum revenue, number of film votes, stars, and Metascore rating. I broke the scraping process into 2 different steps. The first step was to gather all the film and actor information, and the second step was to go back through it all and to create the aggregate fields such as max and average. This was done in Python, and the database I used was MongoDB. These are different fields. Some extra fields that weren't listed before are such as failed. This is if a critical field such as IMDb ID failed. This boolean would be set to true, so later on in the aggregation process, this specific object would be ignored. I created 2 different collections, films and actors, while scraping. Films aggregate was from the second step of the Python process, the aggregation process. Rather than overwrite the original collection, I decided to create a second, just in case something went wrong. I didn't lose data along the way. And then to generate the model, I did that in R and imported everything in from MongoDB into a data frame and continued to create a multiple regression model. The Python scraping process starts by going to Box Office Mojo's alphabetical index of films and going through each row in this table, continuing on to the next page, and then going through each subpage. Information it pulls out along the way is Box Office Mojo's ID for a film. So for example, for the A-Team, it's just A-Team. It pulls the title of the film as well as the year that the film was released. Some rows that it skips are any that have an NA value for revenue. I wouldn't be able to use this information in the model, so I ignore it in the scraping process. The next step is to map this Box Office Mojo film to its corresponding IMDb page. This is done by running a search on the Box Office Mojo title, which doesn't always exactly match the one that's in IMDb, and I get a list of results. So to narrow that down, I use the release date, but because films are released at different times depending on the region and country, the year didn't always match, so I had to implement a tolerance of give or take 2 years to try to find the best result. Once the IMDb page was located, I saved the IMDb ID, which is the ID I used in the dictionary of objects in the backend and in the database, as I found it to be more useful than Box Office Mojo's. At the same time, I also pull information. This is the star rating, as I mentioned before, the number of votes, the director information, Metascore, the MPA rating, time, which is converted into minutes, and any values that are missing, I fill them in with default values such as 0 or none. And there's a certain set of values that I consider to be important that if those items cannot be scraped, then the movie or actor would be ignored. After the film information is saved, the entire cast is then created into an actor object, and then their actor page is scraped as well using the IMDb IDs for actors. Such information that I save here are the birthdays and the number of films that they've appeared in that have been released and have a revenue. In order to make the code a bit more readable and run more efficiently, I created some custom classes to help with the scraping process. One of the classes I called a set queue. It's a combination of a set and a multi-thread safe queue. This allowed me to scrape concurrently, taking every film or actor that I see and toss it into this object, and this object will use the set to make sure that I'm not re-scraping an object, and the queue allows me to pass this set to different threads and not have to worry about any collisions when they run concurrently. A queue consumer is what I use to run on the threads. The object takes an input queue and an output queue, and concrete implementations of this abstract class define the consume method, and depending on the intended functionality, it may scrape an IMDb page for an object or find an actor, link an ID. This was pretty flexible to whatever use, as long as what objects got taken out of in ended up in out. This ran in its own thread and gets started in the main process. And the thread daemon set to true, so when the process exits, the threads quit as well. And the combination of these two objects allowed me to restart if something failed. So for example, if I had already scraped 1,000 objects and saved them in the database and something broke, I was able to restart the code and populate the set within a set queue with the IDs of objects I had already seen, and repopulate the queue with the objects that were waiting before the code exited, so that way I could pick up right where I left off rather than restarting the entire process. For films and actors, I separated their functionality into two different classes. Each one has error handling, accessor and setting methods, aggregation methods that can't be run until the entire data set is collected are separated, and I tried to abstract them out as much as possible, so narrowing and finding bugs was much faster. Actor looks similar to film, but because there are fewer fields to scrape from actor, the class is a bit smaller. When the scraping process is run, the terminal output kind of looks like this. At this point, films have already completed, so you see actors, there are 243,000 left to scrape. Green is when a function completes successfully. Blue is when something is saved to the database. Anything red is when a field I've marked as important fails. So a lot of these actors only appear a single time in a film, so they don't have much information on IMDb, so the birthday often fails. So I'll still save this actor object in the database, but the failed field will be set to true, and it will be ignored in later processing. So after I scraped all the film and actor information and ran the aggregation functions and saved them in the film's aggregate collection, I was able to move on to running the R code. And so in the R notebook, up top is kind of a write-up of my process and some links to blog posts I made while writing everything out. And then it starts off by creating a connection to the Mongo database. And then I pull out the film information and put it into a data frame. These fields I drop immediately as they were only used in the aggregation process, and I didn't want to fill up space and have to remove features from the model later on. So I ignored them. This function right here is what I talked about earlier about mapping the MPA ratings to an integer. So it's just some arbitrary order and map through 1 through 7, and anything that was different from these, I think there are approximately like 18 distinct values, gets set to 0. And then this is the function that takes a rating and maps it back, and then this is applied to the entire MPA string row in the data frame, and then is updated to a new column with MPA num. Some directors didn't have an age, so set to 0. So I fill in that column, or there's specific values with the average age for actors. Some better ways to do this in the future would maybe find the average age for directors in that point in time, such as 2000 or 1953, so it's a bit more specific. Or maybe take a proportion of directors' ages and kind of keep that the same, rather than just take the average for the entire set and apply it across everything. While running these histograms, I didn't run them until after I completed the model and realized that the data was extremely skewed towards low budget and low revenue, mostly independent films. So another improvement for the future would be to create 2 different models depending on the budget of the film, which would give me a more normal distribution, as I'd be able to divide the two into 2 different data sets with data that was more similar. Same thing with outliers. When I ran this code, I got tons of outliers because the average was so low, because it was pulled down by these lower budget and lower revenue films. And then this is an explanation of, I was predicting revenue and outlining which fields I originally used in the model, and then I did the backwards fitting process, and this is the order: average actor film votes to max actor film stars, and I kept going down until everything was statistically significant, and then this is the list of features I was left with. But unfortunately, the R² value for the model was 0.25, which is very low, and so the model didn't really do anything. This was highlighted by my testing process. I did 2 different training and testing sets, one with a 50-50 split and another one with 30-70 split. So this is where I had the 2 different testing models and removed the same fields as I removed from the other model, and use sapply to take each row from the test data frame and use the predict function and the corresponding model. And then to test accuracy, I found the absolute average difference, and for both models I was off by about $47 million. So again, not a very super beneficial model, but in the future, with dividing into 2 different data sets and kind of paying attention to the uniformity and normality of the films going into each set, whether it's low budget or high budget, the 2 separate models would probably have higher R² and be more useful. And this section here is pulling out the coefficients, which would eventually be copied over to the Python interface to run this model, and it's just easier to see than the summary layout. So at this point in time, the Python interface that I intended to create, which would have been a command you ran from the terminal, just run model and pass it to link to IMDb, does not work. This is because I was able to find a way to go from Box Office Mojo to IMDb, but going from IMDb to Box Office Mojo is much harder, as Box Office Mojo's search functionality isn't as powerful as IMDb's, so almost every search result missed. So I'll probably have to end up scraping every movie on Box Office Mojo and kind of creating my own search algorithm. But I have this in my list of improvements in the future, as it's not super useful until the model is better. So again, once I implement dividing the models between high and low budget films to get more accurate results, this interface will become more useful. And then finally, to documentation. Everything is on GitHub with a README of how to run it. Functions have pretty specific comments, and then I also have a branch of how I started to do ad prediction, but I didn't finish it. And then in addition to GitHub, I've been putting blog posts for such as this video's general script, improvements, kind of my thought process and problems I ran into while doing the Python scraper. And then earlier on, before I started the project, kind of my brain dump of what I wanted to accomplish and how I'd go about it. And then the R notebook also has some information up top. Most are links to blog posts, but there's some extra information about kind of backwards fitting, directions, and points for improvement in the future.